our next speaker. So Dr. Gürkan is a senior lecturer at Zurich University of Applied Science, Information Security Group in Switzerland. So he received his BS degree in electrical engineering and PhD in computer engineering from University in Istanbul, Turkey. So his research interests include future internet information security, 5G and beyond networks, and critical infrastructure protection. Currently is involved in Horizon Europe Network and SNSF-NSF co-funded projects. So he's a member of IEEE 3394S2CY Space System Cybersecurity and IEEE 1920.2 Vehicle-to-Vehicle Communication for Unmanned Aircraft Systems Standardization Work Group. He's also a senior member of IEEE and an ACM member. Over to you, Gürkan.
Thanks for introducing me. Yeah, in this talk, I will talk about research methods and dissemination. As noted, I'm Dr. Gürkan. I am from Zurich University of Applied Sciences. I will keep the promotional part short. I'm a member of the Information Security Group there and a member of the Institute of Computer Science. So in this talk, I will talk about more, let's say, soft skills. Just to give you some context, we had a summer school in Zurich, Siren Summer School on human factors in cybersecurity last week. So we had a session there with Professor Ariane Tramel, who is leading our research group. And there we talked about research methods and also dissemination. It was quite a long session compared to this talk. We had some kind of workshops with the attendees as well. So in this talk, I will try to kind of make it more concise and provide you, I hope, some interesting information on these topics. So let me start with the engineering mindset, because this was something we discussed before that summer school, and that was something quite, I guess, interesting for especially early stage researchers like MSc students or MSc students, PhD students, or junior researchers. And when we thought about it, when we looked around, when we tried to kind of formulate the general research approach, we came up with this kind of general formulation. Of course, when we are talking about research approach, we are not talking about medical sciences, we are talking about engineering. And especially in this talk, I will try to put the descriptions and my treatment in the domain of cybersecurity. But if you look at engineering in general, of course, as an engineer, your primary goal is to create a new utility, or you have a defined problem and you want to solve it. An example, for instance, you would like to build an authentication mechanism. Again, I will give examples from security. Then if you want to have this working without passwords, how would you design this, right? So you can come up with these questions, and then you come up with some method where you try to implement some solution to your research question or technical question. For instance, in this case, you may need to come up with a system architecture, you need to do some coding, prototyping, and then some algorithmic optimization, right? So this is like the general approach. And there are different ways to kind of formalize the way we do research or the way we do engineering technical work. There are, again, different examples, but here I'm going to talk about a specific one. This is just an example. You can have similar methodologies, but they are usually following the same approach. I'm going to talk about design science research. So this is a formal framework, and the idea is to make building scientifically more organized, more rigorous. So here the idea is it structures the engineering process, the creative engineering process, into what we want to have as science, reproducible science. And of course, it starts with a question and it tries to answer this. How do we know a specific artifact, something we develop, represents a valid scientific advancement? And this is an important question, again, not just for industrial research, and a very important question we encounter every day when we are doing research on our own or when we are working with graduate students or some junior researchers. And there are, when you look at this kind of process, the research process, maybe you are already aware of this as part of some let's say more organized educational activities, like some scientific research course, or maybe you just learn this when you are doing research with some let's say senior figure like your PhD advisor. But at the end, we usually have this kind of process, right? When we are looking into research. So first we have the motivation. Here, the idea is you look into related work and then you come up with a problem statement. And then you have the development part where you have some prototyping and data analysis. And then you have the evaluation, which is very critical. You look into your system performance, what are the limitations? And of course, you have to come up with some benchmarks. And if you are doing something analytical, you have to come up with some proofs, for instance, some security proofs, if you are talking about security. Or you come up with some simulations. This can be hybrid simulations where you have some real world empirical data, working with some real simulation. Nowadays, there are also digital twins, but the idea is you do some rigorous evaluation. And then, of course, the last part is dissemination. Here, what you do is you write a research paper, for instance, or you go and present at a conference. And also a very important part is to communicate what you do to the public. And actually, this talk works in two acts. In this part, I am talking about methodology, but in the second part, based on time availability, I will also talk about this dissemination part, which can be, interesting for, again, early stage researchers. So, we talked about this. And as I told you, you can have different kind of formulation of this process. I'm going to talk about a specific one, design science research. And here, what we have as the model is like in three pieces. So we have the environment, because when we are talking about an engineering problem, we are talking about some application, some use case, right? And that's usually not just technical, it also has social or economic aspects. So we have people, we have organizational systems, and of course, some technical systems. And then we have some problems and opportunities. So basically, this is what we call what this formulation calls the relevance cycle, because here what you have is your requirements. And also when you are doing your evaluation, this will also serve as, for instance, field testing purposes. And then the second part, by the way, this drawing is not like, a temporal progress drawing. So you have the relevance cycle and then you have the rigor cycle. Let's talk about this second part. Here, what you have is you do some knowledge base, create some knowledge base, which will serve you for kind of coming up with your research. So you have some foundations, for instance, scientific theories. And then, of course, you need to build not just foundations, but also experience and expertise. So again, for a PhD student, for instance, we are talking about courses or some hands-on labs and so on. And then you come up with some meta artifacts. So these are more like, things, products, which are going to be implemented for your actual building process. And that's the design cycle in the middle. So here, what you do is based on the environment, the requirements, and then the knowledge base, you come up with some artifacts and some processes which will allow you to come up with your solution or your contributions. And of course, the next step is the evaluation part, because it's not just proposing something, right? When you are doing research, you also need to evaluate and show that it is better. For instance, it is more energy efficient, it has better detection rate, whatever. But please keep in mind that this model doesn't say like we do these steps and then we are done. It's more like an iterative process where we have a loop or multiple loops which are feeding each other. So you may need to go back to the environment if your if your artifact is not working properly, and then come up with some new design, or you may need to learn about something new. For instance, if you are working on optimization for some cybersecurity solution, you may need to go and look into optimization techniques. So I would like to talk about the idea of artifact, because here I said like we have artifacts, right, as outcome of our research. For engineering research, we call this artifact. For some other domains, it may be something different. And the idea is we have a practical problem, and then we have something designed to solve that technical problem. And here we are not just talking about code. When we are talking about computer engineering or computer science, we are talking about some kind of idea or some theory which is implemented. It can also be a piece of hardware. It can be a process. And here we have several models where we can kind of categorize artifacts. As I told you before, you can have different categorizations, different namings, but this is the blueprint when we are talking about this kind of research activity. For instance, you have constructs, you have models, methods, and instantiations. Now I will just give some examples. So basically, constructs are, let's say, specialized vocabulary or concepts or some taxonomy which you use or which you generate as part of your research. And here, it's really important because this is also related to the dissemination part or the communication part. Here you need to establish a standardized and clear language. For instance, if we look into cybersecurity, we have things like zero trust concept, right? That has a specific meaning. Or when we are talking about vulnerabilities, we talk about attack surface, or we talk about indicators of compromise. Or when we are talking about some specific threats, we say we have this and that, and we also have privilege escalation. So these are like specific concepts, terms, which are really important. And these are, again, generated during research. Yeah, and then you can even have more kind of formal descriptions, which are part of standards or some frameworks. The second thing is models. And here we have some architectures or models which show the interaction of those constructs. And here the idea is you try to come up with these models, which are not perfect, but they will give you some predictions, or they will allow you to analyze system behavior. Here there are famous examples. For instance, there is, again, I'm making cybersecurity examples. Here we have attack framework from Maitre, or we have the threat model Stride. So these allow you to come up with these constructs which allow you to understand systems. And then we have methods. So here, this is usually what we have as contributions when we are talking about academic research. We have algorithms, protocols, maybe some playbooks for security, and they are basically step-by-step procedures. And here, of course, the purpose is to come up with some structured approach and to have some repeatability, like reproducibility. And from the cybersecurity domain, for instance, you may have an alert correlation algorithm for your security incident and event management system. You can come up with an encryption process, or if you are running a security operating center, you may have some playbooks, some response mechanisms. Here, for instance, you see an example, a technical one. Here, how you kind of design a message authentication code to ensure integrity and authentication. There may be other examples. And then you have your constructs, you have your models, you have your proposals. And of course, as an engineer, the next step is to come up with some instantiation. So you have to implement a system. It may be a proof of concept, a prototype that basically entails these artifacts. And the idea is, of course, to prove feasibility as realistic as possible, and then to show that it is effective, because you are proposing this against some research questions or research problems or technical problems. And here, of course, we are talking about when we are talking about security, we can talk about a specific security tool, or if you are doing vulnerability research, you come up with a patch so that the system is fixed. For instance, if you are using Microsoft Defender on your machine, that's an instantiation, right? There are different algorithms, artifacts, which are implemented for a specific solution. If you would like to take a look at a specific example and an interdisciplinary one, because phishing is not just a technical problem, it's also a social engineering problem. So for instance, here you see an example kind of mapping for automated phishing training. You may ask why we picked this example. The reason is basically we had a research project with an industrial partner where we looked into phishing training for, for instance, for employees of a company so that they are more resilient against phishing attacks. So here you come up with some terminology like susceptibility rate, phishing queues, or cognitive overload when someone is working, or you have some models. Here you need to come up with a model, for instance, which is going to show what cognitive overload, or to what level it goes when you have a different kind of setting in terms of phishing, and then you need to come up with some method where you implement the phishing training in an automated way, and then of course you need to implement it to come up with an instantiation. So here the idea was to come up with an Outlook plugin which will allow you to train your employees against phishing attacks. So coming back to the model that we just talked about, I would like to focus on the evaluation part now, because this is also something really, I think, critical, and also something we always discuss among ourselves and also with junior researchers. So here I'm going to basically talk about evaluation in engineering. So when we say evaluation, of course, we are going to evaluate our artifacts, because these are kind of the outcomes of our research, right? So there are different methods. Maybe as network security researchers, we are not doing that much, but there is, for instance, the expert evaluation one. So you can just present your constructs, your models, methods to some experts so that they can kind of provide you some evaluation. An example here is, let's say you come up with a new zero trust architecture model, and then you present it to a panel of experts. And then there is the mathematical proof, more analytical approaches. And here, this is especially relevant for instance, for applied cryptography, right? Then you have your method. Let's say you have a new crypto protocol for post-quantum cryptography based broadcast authentication. And then you need to formally verify it if it complies with some security properties. And then there is simulation for evaluation, which is very commonly used for our research. Here, again, we have our method. For instance, we have a new anomaly detection algorithm. And then we evaluate it using simulations. For instance, we find a public data set, not NDD1 or KDD, whatever, something more recent. And then you look into your machine learning algorithm to see how it performs in terms of some metrics. And then we have the performance evaluation. Basically, here you are just kind of using more hands-on stuff, because you take, for instance, your implementation. It may be, I don't know, for instance, machine learning based orchestration scheme for 5G networks for security. Then you have your 5G testbed with UE runtime, for open 5G core and so on. And then you try to see, you run an attack and see how your solution behaves. Then you may have more metrics or KPIs measured, because this is not just detection rate now. You are talking about a more realistic system. You can measure things like packet loss, what happens to the latency and so on. There is also case study method. This is also something which is really relevant for cybersecurity, but usually as network security people, I guess we use it less often. And here, if for instance, you have your method, which is, or a tool, which is an instantiation about incident response, and you just go and do some kind of investigation at a real company to measure what happens. Of course, this is also related to performance evaluation, because if you do this like a use case scenario, which we usually do in this, big projects, that may also include performance evaluation, but this can also be like a case study. So here, there are some methodological blind spots, and these blind spots come up. You may ask why, because this was, presented as part of this interdisciplinary cybersecurity summer school. So that's why they are kind of here, but I think they are also important for our group as well. Because when we look at engineering in terms of internal validity, we really strive to be good, right? For instance, we write code, we test it, we show if this code is for let's say if we have some kind of instantiation, we see in terms of performance, does it really meet the requirements and so on. And also there is the other side of the coin, because when we design these systems, they may be technically, let's say, perfect, but they have to exist in kind of like in real life, right, in our society. So this is something which we usually kind of struggle with, because this is related to the question, does it work in society, right? And this is something which is really interesting in terms of research. Maybe some parts are not that technical, intellectually, stimulating for technical research, but they are really intellectually stimulating if you're thinking about the overall research, because here you can come up with some interdisciplinary research. Again, coming back to my comments, we can kind of formulate different research problems and integrate different methods to come up with some more interdisciplinary solutions, instantiations. Yeah, so I will just make a few kind of takeaways here, just to recap this first act, the first part. So basically, when we are talking about engineering research, we are trying to solve practical problems, but not just like in a chaotic way. We are trying to do it in a structured, reproducible way. And here we need to focus on some key aspects. Forget about DSR. We need to have relevant research problems for real systems. We need to have rigor, so scientific approach, and then we have to come up with some contributions, with some artifacts. And here, as I just made like some comments on the previous slide, interdisciplinarity is really important. Okay, so yeah, in the 5 or 10 minutes remaining part, I will talk about some more a more concrete example and some things about dissemination. So here you see an example, a concrete example regarding cybersecurity research. This is a PhD work by a student who worked with me and with Burkhard Stiller at University of Zurich, and that was done last year. And this was also part of 2 EU projects. This is also relevant because Matsusanka was in the PhD defense committee. Yeah? So here I will just give some examples very quickly about how we make the connection to this methodology in terms of what was done in the PhD thesis. So we came up first with some research questions and gap analysis. This thesis was about moving target defense in future networks, so 5G and beyond 5G. At the beginning, 6G was more, we were like more shy to say 6G. We would say beyond 5G, but now we call it 6G. So we looked into the related work, we formulated some research questions, and then we come up with a model, an architecture. So this was implemented as part of the thesis with different elements. And then based on this, this model and new constructs like metrics and KPIs, we had a test bed where we could test our proposals. And this test bed was a test bed at NCSR Demokritos in Greece. And there we use some methods like machine learning, federated learning, simulations, heuristics, and also network simulations so that we could show our methods were working. And we use some evaluation methods. As I told you, we use simulations. We did some performance evaluation based on our test bed. And also we did a case study related to use cases in the Inspire 5G Plus project so that it was kind of following almost all the methods which I described before. And the name of the framework was Merlins. That's why you see Merlins here. And there were different contributions and publications. So if you are interested, you can take a look. But, you know, this kind of methodology, you may have your own methodology, but as long as you have this general flow, this kind of methodology will help you with your research. Now, the second act, the dissemination act. I will just briefly talk about dissemination because this is something quite challenging as far as I see for students. I know now we have generative AI and the cycles are getting shorter, but you have to learn about this stuff when you are a junior so that you can use those tools more efficiently in the future, right? So this is a presentation which I have used for different courses because this is something I use to level graduate students working with me as research assistants, as students attending my seminar course, and I will try to be brief. But here I'm going to talk about how to read and deconstruct literature, let's say, or body of research so that you can write technical papers. Here, again, these are just ideas. They are not really rocket science. They are not that original, okay? These are some things I learned along the way. So the first part is related work. Now, yeah, this is much easier, right, compared to 30 years ago because we have these online sources and we can, you know, even use LLM-based tools now. So they will provide us a lot of information. But I think there are two elements which are really important here. The first thing is to discuss what you find with your fellow colleagues, that may be other students or your professor. That's why you have an advisor, right? And the second thing is the quality. So now we have a lot of noise. So here you need to be able to kind of focus on the quality, and number of citations is not the only metric. There is also the experience part. That's why, again, your PhD advisor is really important. And then as a method, what I do is, what I suggest to students working with me is hope by hope investigation. Maybe you already do this. So you pick up the right words, and then please record your keywords and which resources you received, because if you go for a systematic literature review in the future, you don't have to go back and find those keywords and numbers. And then what you need to do, I guess, is to categorize papers, because you have a lot of papers. For instance, what I do is there is the fundamental paper or papers, maybe some surveys and tutorials, some slightly relevant, and then very relevant papers. And usually the very relevant paper for a thesis or for a project should not be, I mean, this is a magical number, but it should be up to 5 papers, okay? If you have like 35 papers, maybe you are not doing the right research. You are not working with the right research question. And then here, of course, the intuitive rule is once the relevance goes up for any resource, the time you spend goes up as well. And then you do paper hopping. So you can do, for instance, three-depth search. So you can look into citation maps, like paper 1 cites paper 2 cites paper 3. And also you can use some heuristics like, okay. I think this is not moving because I dropped waste. I think I dropped from the meeting. No internet connection, okay. Okay, I'm back. Can you hear me again? Oh, I'm muted by default. Can you hear me? Okay.
Yes.
Okay, thanks. I'll just share it again and I'll be quick. Okay. So I was talking about this second part where we have this kind of graph-based search for related work. And of course, it's not just this graph. You can also, once you start to read, you find some influential authors, some persons, some labs, some projects. So these are really helpful to see what's going on. And also some significant venues. So if you are doing intrusion detection, there is the RAID conference, or if you are doing offensive security, there is VOT, NDSS VOT, for instance. You can come up with different examples. And then you need to read these papers, and this is from Keshav, Professor Keshav, but this is very intuitive, right? So you can use something called 3-pass read, where you can kind of progressively look into a paper, and it based on like what you have in the previous pass. The more relevant the paper, the more time you spend on it. And now comes 2020 or 2020's slide, generative AI usage. This is something I integrated recently. So this is from 2025 slide deck. So last year, you can see when you see the other slide, I was quite more conservative about generative AI usage. Basically, I mean, it's the same, but there was a lot of exclamation marks, be careful, be careful. It's still the case, but nowadays it is more organized, right? So here you see from NDSS 2027 call, the explanation of how to use generative AI, or if you use it, how to declare it. Here, there are a few key elements. I think these have not changed. I mean, we are all using these tools, especially students. First of all, there should be no plagiarization. You should not misrepresent anything. And once you have something which is, assisted by generative AI, you are responsible for it. You have to check its validity. If something goes south, you are responsible for the consequences. So there is this liability aspect. And at the end, it should be used as an assistive tool, but it should not write, for instance, the papers for you. And another thing is transparency. So this is like the second paragraph. This is a nice example. You can find other examples. You need to disclose what you do with generative AI. So you have to be transparent about what it was used for, which sections, for which purposes, and so on. So this is really important for research nowadays. And when we say research, of course, when we are talking about dissemination, we are talking about publications. Of course, we are not talking about publish or perish case, but you have to disseminate your research, right? And this is quite challenging. Here you see some top security conferences ranking. This is no official ranking, but as you might see, it's very challenging to get your work published in one of the top conferences, security conferences. Here, what you need to do is basically perseverance. So you need to kind of improve your work and be persistent so that you have some good kind of impact based on your research. And here, ideas are really important. And to come up with ideas, you should not just ask ChatGPT about ideas. You need to read and understand stuff so that you can think on your own. And that includes testing and being a skeptic, which includes trying to kill your own idea. You can also ask your peers to do that for you, like the person sitting next to you in the lab. But of course, you have to be self-confident, right? You have to defend your ideas. And once you have your research outcome and you have some reviews, sometimes this is quite demoralizing, but at the end, sometimes they are not really helpful, but at the end, they will allow you to improve your work, right? And here, another important social element is to discuss with your advisor, but not just your advisor, your peers and colleagues about what can be done to improve your work so that you have better contributions. And always remember, reviewers are not paid. So people are doing community work, let's say, when they are trying to write good reviews, and that's challenging. And of course, there is the plagiarism topic, which is now more challenging with generative AI. And this is something you have to be very, very careful because this is unethical, first of all. It's theft. And it's not just for this moment. It can jeopardize your whole career, okay? So coming full circle, I just used more time than I'm allocated for. But anyway, at the end, you are a member of scientific community, okay? Be proud of what you do. So share and discuss your work with other people. Practice is really important. Publishing is nice. Again, we are not talking about publish or perish, but you need to disseminate your work. And that doesn't have to be just publications. You can write technical reports. You can write blog posts. You can give talks when possible. And also put this in on an academic website. I know now we have Google Scholar and so on. Yeah, but anyway, you should also have your kind of own space. And at the end, always be nice, because as geeks, sometimes we are quite, not nicely behaving against other people during, let's say, conferences, during presentations. This is really important. So thank you. Thanks for listening. If there are any questions, I would be more than happy to answer. Thanks.